Hey guys, welcome back. I'm calling this video 20 and 21. There's going to be two problems on the same video because both of these problems are not going to take us a long time to do. So, with that being said, this is number 11. A ladder 10 meters long is leaning against a wall, a vertical wall with this other end on the ground, the top end of the ladder sliding down. So let's draw a quick picture of the wall. We can do this and this. Okay, great. And here's our ladder. It's 10 meters long. It's sliding down. So we're going to have a negative answer. When the top end of the ladder, when the top end is 6 meters from the ground, so great. It is sliding down at 2 meters per second. So 2 meters per second. How fast is the bottom moving away from the wall? So how fast is this part moving away from the wall, right? So basically what we're doing here is we're seeing this part is going to become just like this here as the ladder's length comes now this way and this way and so on, okay, until the ladder falls on the ground. So we are looking for, I'm going to call this guy A, this guy B, and this guy C. I hope everybody remembers that this A is going to be 8 because it's a 6, 8, 10 triangle. And if you don't remember that, you can use A squared plus B squared equals C squared, which is our formula. Excuse me, I'm going to take the derivative. I'm going to go 2A dA dt plus 2B dB dt equals 2C dC dt. All my 2's cross off. And then I'm going to have A to be 8. I'm not too sure. B to be 6. I'm not too sure. And C to be 10. And now we can talk about the rates of change. So with the 6 comes a negative 2. Okay, so that's this here. With the 8, I'm trying to figure out how that's changing. And we're going to call this dA dt. And remember from past videos, the length of this ladder will stay consistent the entire time. Therefore, dC dt equals 0. Remember, the ground is changing and the height is changing, but this ladder won't change. So that's 0. So we have 8 dA dt minus 12 equals 0. And then we're going to add 12 and divide by 8. And therefore, I'm going to have dA dt equal to 12 eighths, which reduces to 3 halves. And it's meters per second. So don't forget your units. So that's how we do number 11. And now I'm going to have to erase everything because I'm going to keep number 12's information on this. So you can pause the video and you can try, you can rewind it and watch whatever you want to. That helps you guys, okay? So this is number 12. Gas is escaping a spherical balloon at a rate of 4 cubic centimeters per minute. Just remember, it says cubic centimeters per minute. Remember, I always have to emphasize this because it really helps you. Minute is time, cubic is volume, okay? So that can help you understand that the 4 is going to be dV dt. How fast is the surface area shrinking? So how fast is this shrinking when the radius is 24? Okay, so let's take a look at S equals 4 pi r squared, okay? Because we want to know how fast is the surface area shrinking, what I want to do is I want to take the derivative of surface area. So that's ds dt. 4 pi is going to be a constant. R squared, the derivative is 2r dr dt. Now, they gave you this, so I have information right now on R. because they said when r is 24. My problem here is I don't know what dr dt is. So I'm going to have to solve for dr dt using this here, this volume, because I have information about the way the volume is changing, okay? So let's do that. I have to erase the 4. I need some room. And I'm going to say dv dt is equal to 4/3 pi times 3r squared dr dt. Now some math. 3 cancels out with the 3. You guys notice how 4 pi r squared is the surface area? So dv dt is equal to 4 pi r squared dr dt. Okay, so here I'm going to put my number 4 pi. I have 24 squared dr dt. And then some math. If I divide this, I'm not going to even multiply 24 squared times 4 times pi. I'm just going to divide because I see a 4 on both sides. So that's going to be 1 over 24 squared pi equals dr dt. So here, I'm going to substitute that here. I have 1 over 24 squared. Remember, 24 squared can be written as 24 times 24, and then pi. Now, some of you might see why I did that. The 24 in the numerator cancels out the 24 in the denominator. What else? We have the 4 in the numerator cancels out with the 24 in the denominator. That's 6. What else? The pi cancels out with the pi. What else? 2 cancels out with the 6. You're left with 3. So this entire time, I didn't need a calculator for all these big numbers because I knew a lot of things canceled out. So many times, don't even multiply everything. Just see if things in the numerator cancel out with things in the denominator. You're left with 1/3, and we know it's ds dt, and the time is minutes, so that's on the bottom, and surface area, so square centimeters. So this is our answer. Okay, so I hope that makes sense. You can watch this video a few times if you still need help, and you can actually leave a comment and I will answer your question. Have a great day.